In a universe already brimming with cosmic mysteries, NASA's James Webb Space Telescope has just uncovered something astonishing. Astronomers have discovered what they're calling Red Monster Galaxies, ancient, enormous, and shockingly dense objects that defy our current understanding of the early cosmos. These mysterious cosmic giants are rewriting the rules, challenging everything we thought we knew about galaxy formation, evolution, and the early universe itself. How could galaxies so massive, so dense, and so ancient even exist? Stick around, because today we dive deep into one of astronomy's most exciting recent discoveries: the Red Monster Galaxies, revealed by the brilliant infrared eyes of the James Webb Space Telescope. Since its launch, the James Webb Space Telescope, often hailed as humanity's most advanced astronomical observatory, has been peering through cosmic dust clouds, capturing faint infrared light from galaxies billions of light years away. Its unprecedented clarity and sensitivity allow astronomers to see deeper into space, and thus further back in time than ever before. Just recently, Webb spotted a set of galaxies so massive, so red, and so unexpected, researchers initially doubted their own data. These galaxies, nicknamed Red Monsters, appear mature, fully formed, and incredibly dense, despite existing in an era just 500 to 700 million years after the Big Bang. To put that into perspective, our universe is about 13.8 billion years old. These galaxies existed when the universe was still very young, less than 5% of its current age. The term red monster comes from the galaxy's extreme brightness in the infrared spectrum. Their intense infrared glow indicates massive amounts of dust and older stars, elements typically associated with much older galaxies. But here's the paradox. Conventional models of galaxy formation suggest that at such an early epoch, galaxies should be small, chaotic, and relatively primitive. Instead, these red monster galaxies are mature, structured, and astonishingly massive, some containing as many stars as our modern Milky Way galaxy, yet packed into a region much smaller and significantly denser than expected. Why does this discovery matter? Quite simply, these monster galaxies challenge our current understanding of cosmology. Until now, astronomers believed galaxy formation was a gradual process where small galaxies slowly merged over billions of years, eventually building larger galaxies like our own. But the existence of these red monster galaxies, fully developed so soon after the Big Bang, suggests there must be another pathway, another mechanism, that allows galaxies to grow rapidly and mature much faster than previously thought possible. This finding could rewrite textbooks, forcing astronomers to revisit and revise their models of early galaxy evolution. In essence, Webb's discovery pushes the boundaries of known physics, suggesting we're missing a crucial piece of the cosmic puzzle. So how exactly did astronomers find these mysterious red monster galaxies? The James Webb Space Telescope operates primarily in infrared wavelengths. Unlike visible light, infrared radiation can penetrate dense clouds of cosmic dust, allowing astronomers to see objects hidden behind massive dust clouds and across unimaginable cosmic distances. When researchers analyzed Webb's first deep-field images, pictures capturing tiny, distant patches of sky with remarkable clarity, they noticed these intensely bright red objects standing out among countless faint galaxies. Initially, astronomers thought these red galaxies might be errors, artifacts, or unexpectedly bright foreground objects. But after careful verification, reanalysis, and cross-referencing with other datasets, they confirmed the galaxies were indeed real, distant, and massive, existing far earlier than standard cosmological models predict. To better understand the implications, let's briefly explore how galaxies normally form, according to current theory. After the Big Bang, the universe rapidly expanded, cooled, and eventually allowed neutral hydrogen atoms to form. Over millions of years, gravity pulled together hydrogen gas into dense pockets, eventually igniting the formation of stars. Early galaxies were supposed to be small, irregular, and chaotic, essentially messy clusters of young blue stars. Over billions of years, these smaller structures merged, collided, and slowly evolved into larger spiral and elliptical galaxies. This slow and steady narrative has been the cornerstone of astronomical theory for decades. But the Red Monster Galaxies discovered by Webb simply don't fit this model. Instead, they appear as fully mature structures, densely packed with older, redder stars, and filled with vast amounts of dust. This suggests star formation in these galaxies was incredibly rapid, intense, and short-lived, creating massive stellar populations in an extremely compressed time frame. But how could star formation happen so quickly and intensely in the early universe, when conditions were presumed to be more primitive? One possible explanation is that these galaxies formed through massive bursts of star formation, fueled by enormous amounts of gas, funneled into the center regions of these galaxies. These starburst episodes would rapidly generate massive stars, which then quickly evolved, exploded as supernovae, and produced large amounts of dust and heavy elements, enriching the galaxy at a rapid pace. However, even this explanation presents challenges, as traditional models struggle to explain how such enormous gas reservoirs accumulated so quickly after the Big Bang. Another hypothesis suggests these galaxies may represent a unique and rare population of early universe objects. Perhaps environmental conditions in certain regions of the early cosmos allowed these monster galaxies to form rapidly and become dense far sooner than elsewhere. Understanding the exact conditions and processes behind these galaxies, their unusual density, rapid growth, and mature stellar populations could provide critical insights into new physics or unknown mechanisms at work in the earliest epochs of cosmic history. To probe these mysteries, astronomers are now planning detailed follow-up observations with Webb's powerful instruments. Spectroscopic studies, which analyze the light emitted by these galaxies to determine their chemical composition, star formation rates, and precise distances, are already underway. By carefully measuring how light shifts, known as redshift, researchers can pinpoint exactly how far away, and thus how old, these galaxies really are. Early results confirm high redshifts, placing these galaxies firmly into that critical early era less than 1 billion years after the Big Bang. Future studies will aim to determine the exact chemical makeup, stellar ages, dust characteristics, and star formation histories of these enigmatic galaxies. This discovery also highlights the immense potential of the James Webb Space Telescope. Webb's ability to detect faint infrared signals, penetrate cosmic dust, and see farther into the past than any previous observatory is revolutionizing astronomy. In just its first year of operations, the telescope has already challenged fundamental assumptions and opened entirely new avenues of research. The Red Monster Galaxies are just one example of Webb's transformative capabilities, suggesting there are likely many more cosmic mysteries awaiting discovery as astronomers continue to analyze Webb's data. Beyond their scientific significance, these galaxies also spark imagination and curiosity. Imagine standing on a planet orbiting within one of these densely packed galaxies. The night sky would be filled with brilliant red-hued stars, intense star-forming regions, and vast glowing clouds of dust and gas. The cosmic environment would be intense, vibrant, and dramatically different from our relatively calm Milky Way. Such galaxies remind us how much we still don't know about the universe and how much there is yet to discover. In a broader sense, findings like the Red Monster Galaxies remind us that science isn't static. It's continuously evolving, adapting, and rewriting itself as new data emerges. Astronomers embrace these kinds of surprises, knowing that each unexpected discovery pushes humanity closer to understanding the true nature of the cosmos and our place within it. So what happens next? As astronomers continue to study the Red Monster Galaxies, new theories and explanations will undoubtedly emerge. Some ideas will be tested and discarded, while others will open entirely new fields of investigation. Thanks to Webb's ongoing mission, the coming years promise to be some of the most exciting and transformative in the history of astronomy. If you're as fascinated by this discovery as astronomers around the world, keep following the James Webb Space Telescope's journey. We're living in an extraordinary era of scientific exploration, and these mysterious red monster galaxies are just the tip of the cosmic iceberg. Stay tuned, keep questioning, keep exploring, and don't forget to subscribe and follow along as we continue uncovering the universe's deepest mysteries together.